Hello everyone, welcome back to my YouTube channel The DB Talks. And today in this video we are going to explore self-join, which is one of the most misunderstood concept in SQL. So we will divide this video in two parts. In part 1 we will see a theory walkthrough, what is self-join, myth busting, how it works, what are the different key use cases. In part 2 we will see a quick query execution and the result analysis. So in next 15 to 20 minutes we will be master of self-join in SQL. So let's begin with the first part. So what is self-join? So self-join is not a type of join. So it is just a technique or a usage pattern which we used in SQL queries. So the fundamental and the standard joins in ANSI SQLs are like inner join, left outer join, right outer join, full outer join, and the cross join. So this self join is a technique where we query the same table twice with different aliases. And the magic happens when we treat one physical table as a two logical entities to reveal the hidden relationship within the data. In our case, we will select employee table as an employee and the manager table, and we'll try to like establish the relationship and find the data within those table. So let's begin with a practical example. So let's understand this example. So here the question is we need to prepare SQL query to show employee and their manager details as shown below. So from employee table we need to show employee number, employee name, job, salary, these four columns, and along with that we need to show their manager details. These are the three columns from the manager table. So now understand this employee table. So this employee table has like employee number, name, job, salary, and there is a one more field that is a manager ID. So what does this manager ID? What is the use of this manager ID? So this manager ID defines the self relationship. So it is given that this manager ID is referencing to the employee number of the same table, and that's why we call it a hierarchical data. Now one question might come in your mind, why we need to maintain this column in the same table? Can't we have like two different tables? Can we data model in such a way that there can be an employee table, there can be a manager table to keep the thing simple? uh, so at high level, yes, we can do that. But if you think employee and manager, these are not like two different entities. So all the managers are nothing but a company employee. They do have an employee number, name, salary, joining date. So manager is just a designation they are having because someone is working under them. And if we try to create a two separate table, and then we need to show how many employees working in my company, then again you need to combine those two table with the help of union. That will be the first challenge. Another challenge is, let's say one employee can become manager at any time, so you need to move that data to the manager table. That will be the second challenge. And the most important thing here is, so it's not just employee and their manager information. So if you see this data clearly, so for example, see Jones, see there is a Ford. Who is the manager for Ford? 7566. So Jones is the manager for Ford, correct? But Jones is also having a manager that is 7839, which is King. So it's like a multiple hierarchical data. So the topmost hierarchy here is King, who is the president of company. Under King, John is working. Under John, Ford is working. So if we create simply a two table like employee and like manager, so we cannot solve this relationship. So there can be like multiple level of hierarchical data like manager, immediate manager, ultimate manager kind of thing. So that's why there is a simple one table is there, that is nothing but an employee table, and the hierarchy is maintained with the help of this manager ID column. So now that's why the self join comes in picture. So when we want to like reveal this relationship, we have to use the self join concept. So we have to treat this employee table as a two different entities. That is nothing but a logical entities. The first entity is as an employee, and the another employee as a manager to like derive this particular relationship. So to derive this data from the employee and the manager table. So let's try to visualize this data in the next slide. So here, okay, it's our main employee table, and from employee information, what I need employee number, employee name, job, and salary, these four columns. So let's visualize that there is a table which is having these four columns. So employee number, employee name, job, salary. But along with that, I also need their manager ID as well to derive the relationship. So let's assume that we have this table virtually, which is having employee as E. So this is my first table employee, which is having like those of four fields, and I took a manager ID as well because I need to find out who is the manager for a particular employee. So this is the first table. So I'm not like physically splitting this table. I'm just logically splitting this for the visualization purpose. So in the SQL, you can refer the same table multiple times, and you can also give them the different aliases to reference which table it is. So this is my first table as an employee. Now I need the manager details. So for manager, I need the manager ID, name, and the salary. So employee number. So manager's employee number is nothing but the manager ID. Manager's name is nothing. Employee name is nothing but the manager name, and the salary is nothing but the manager's salary. And if you see this manager ID, it is even available here as well in the first table, and it is available in the second table as well. But I will refer it from the second table. Don't get confused at the moment. We will clarify the things once we write the actual query. So what I'm doing now, this is my second table as a employee as M, and this is my table. So I'm using two aliases. One is E as an employee and one as a M as a manager to like differentiate it and refer the columns from both the tables. Now the ask is very clear here. So these are like two tables visually I am having. I have logically splitted these two table, and now I need to like establish the relationship in these two table. So by self join, because it is the same table I'm treating once as a E and once as a M, and now I need to perform any kind of join. So let's assume that we are going to perform an inner join in these both two table. Now the most critical and the important concept here is how to join these two table. So most time the user or the everyone get confused that which column I need to use, because when they visualize this simple table, so they can't figure out that how which column is used. They might get confused that is the employee number or the manager ID, which column is used. But now as you see, this table are side by side, and what is my ask? So to find the manager information for a Smith, that is nothing but a 7902. So I need to look up this 7902 in this particular table, which will match here. This is my 7902 column. So the condition is very simple. I need to look up my manager ID from employee table, and I need to look up in employee number field, which is in the manager table, to figure this out. So my join condition will be manager ID from the employee table is equal to manager dot employee number from the employee table. But if you see now, this is the equal join, and manager ID from the employee table is equal to the employee number from manager table. So this manager ID, I can either take it from this table or I can take it from the this table. So I can get it from any of the table because this is my common key column. So now let's prepare how the query will look like. So just let me reiterate. So this is my employee table, and this is my manager table, which I have which like logically splitted, not physically. And my join condition will be employee.manager ID is equal to manager.employee number. And how my query will look like? The query will look like this. So if you see here, all the blue fields are coming from the employee table, whereas all these three fields are coming from the manager table. And the join condition is employee.manager ID is equal to manager.employee number. So this is the most important condition. This is the most important condition here that I will be using in my select query. E dot manager ID is equal to m dot employee number, and this is how the query looks like. And for simplicity purpose, we have used the inner join here, so that we'll discuss whether can we use any another join as well. So but assume that for now. So once we identified that these two table logically as a two different entities, so that is my self join, because we are joining the same table, and with the help of this is the linking column between these are the like two linking columns. My condition here is e dot manager is equal to m dot employee number. So it's a inner join. So now let's see how this join operation let's see how this join operation works. So my employee table, so the first record is king. So king is like he's not having any manager ID because he is like in topmost in the hierarchy. He is the president of the company, so he does not have any manager. So what will happen? This record will not come into the result set because we are using the inner join. And what inner join says, only the matching record from both the table. That is what the inner join says. So this record will not come into the picture at the moment. Now the second record, which is nothing but a Smith. So now who is the manager for Smith? Manager ID is 7902, and if we try to find out, this matches here. Ford. Ford is the manager. So this whole record and this record should come here in the output result set. So for Smith 7902, Ford is the manager. So this record will come here, Smith and the Ford. So this is my first record. Now again we need to go to the second record. So second record belongs to the Blake, and who is the manager for Blake? So 7839. So that is nothing but a king. So Blake is the manager. So that's might be the case because that's the reason that king is the manager for Blake, because he is topmost in the hierarchy. Now so this record Blake and king will come here in the output. So this is my Blake and this is my data from the manager table. Now the next record is like Adams. Adams is working under 7788. 7788 belongs to Scott. So for Adam, the Scott is the manager. So the hierarchy will be like Scott and manager. In the result set, they will come as Adam and the Scott. And the next record belongs to the Ford. So 7566 belong to again manager Jones. So that record will come in the picture. And similarly for the Jones and for the Scott, the data will be derived here. So if you see here, there are total like 1 2 3 4 5 6 7 records are there, but in our output we are only getting the 6 record. Total 6 records are only there, and this one record king, it did not came because we are using the inner join, and inner join says only the matching data from both the table. So that's why this record did not came into the picture. But this is how the self join works. So we can, based on our requirement, we can use the inner join or any another join, that is left join as well, to join this two table. But it's not a like, so as I mentioned earlier, so self join is not a fundamental type. It's just a concept or a joining methodology which we use to join the same table twice to derive such kind of hierarchical data. Now just one more point. So if we want to, there's a requirement that we need to show all the employees whether they have any manager ID or not, whether they're working under any manager or not. So we want this king's record also in the output. So what we can do, so inner join only gives the matching records, but we need all the data from the employee table. So we can change our join condition, we can change our fundamental join. So from like inner join, we can switch it to the left join. So let me, okay, so now we are switching to the left join. So what does this left join does? So whichever table is on the left hand side, that is nothing but the employee table E. So it gives all the data from employee table. So there are like 7 records, so all the 7 records will come here, and only the matching data from the manager table, because this table is on the right side, that will come. So as of now there is only one record which is not matching, that is nothing but a king. So that will also come into the output. So if you see here, and for the remaining one, there will be null values. So for the remaining one, there will be a null values here from the manager table. And you can alias also, means we can alias this column as like as manager ID, manager name, manager salary, because they are coming from the manager table. And employee, we can alias it as a employee number, employee name, job and salary. So we can alias it for the better understanding. And this manager ID column, we can either refer directly from e.manager ID as well, or we can refer m.employee number, because this is an equality condition. So to derive this column, we can use either this field or either this field. Any of the field is perfectly fine. And another record will come as it is from the inner join perspective, which we have seen in the earlier example. So this is how the inner join works. So the main thing is that inner join, so self join is not like a specific type of join. And if your interviewer asks what are the types of join, so you shouldn't be saying that either self join is a self join or like a natural join. The fundamental joins are only inner join, which is the most widely used, then left join, right join, full join and cross join. So these are like 5 joins which are the fundamental joins. And self join is just a concept where we like join one table with the itself only to derive the hierarchical information. Now let's see a practical example in the next slide. So let's start a demo on self join. So I will be using the employee table. So let me show you the data. So there are 7 records in the employee table, and as usual, King does not have any manager ID because he is the topmost in the hierarchy. So this is my employee table, and we need to refer this employee table as a twice by splitting it logically, and one as an employee and one as a manager. So we need 4 columns from the employee table, and we need these 3 columns from the manager table. So this is how the SQL looks like. So let me. So this is how the SQL look like. So here if you see in the from clause, so I'm referring employee table as a E, and then inner join employee table as a M. So I'm referring this employee table twice in the join operation, and I'm aliasing it as a E and M for like employee and manager. And the join condition is E dot manager ID is equal to M dot employee numbers. This is the most important condition for the self join. So here I'm referring the manager ID of the employee table, and then I'm doing the lookup into the manager table of the employee number. So I'm doing the lookup in the employee number of manager table. So this is how the join condition is, which we have seen in the presentation. So this is the query, uh, how the self join looks like, and let me run it for you to show you the output. Okay, so this is the output for this self join. And if you see, these first 4 columns are coming from the employee table, whereas the next 3 columns are coming from the managers table, that is as manager M. So let me add one more column to like just like derived column to see who is working for whom. Dot employee name, and I will say mm, employees manager is. I will add the manager's name here as. Okay, so what I did here, I have created a derived column which says employee name, and I just concatenated and added one as here. Manager is and I have added manager's name for the just for the better understanding. So let me run it again. Okay, so now if you see this particular query, so these are the 4 columns from the employee table, and this column just shows the relationship. So Blake's manager is king, Jones manager is king, and Ford's manager is Jones, kind of thing. So just for like better understanding. So this is how self join. We can refer the same table employee. We can refer it multiple times as per the need. So right now we just need to like derive 2 levels of hierarchy. So we are using this table as a twice only, so one as a E and one as a M, and the join condition is a E dot manager ID. So this is how the self join exactly works. So self join is like a technique or like a usage pattern where we join both the table with the same name by giving them a different aliases, and then we use any standard join method, that is maybe inner join and the left join. Now the question is, so there are only 6 record in the output. So King's record did not came in the output because King does not have any like a manager, and this is the equi join, the inner join we are using. So inner join only gives the matching data. So now let's convert it into the left join to get that employee record as well, King's record as well. So when we say employee E left join employee M, so all the data will come from this table, which is on the left hand side of the left join. So in the left join, employee table is on the left hand side, so all the data from this employee table will come whether it is matching or not into the second table, that is in the manager table. So this is how the left join works. So now let me run it, and now there are 7 records in the employee table. So we are getting all those 7 records. So if you see here, all those 7 records we are getting here, and King does not have any manager, hence the manager information is blank. And let me handle okay, so here it shows null because there is no manager. So just let me put it as that he is a CEO whenever there is a null. So let me handle it with the help of coalesce. So I will say coalesce of whenever there is a blank, just replace it with the CEO. So it is just for just a dummy value whenever there is no value present. Okay, so what coalesce will does, whenever there is a blank, it will be replaced with the CEO text. So this is now this is the final query, and if you see these 4 columns from the employee table, and this is the This is from the manager table. So I hope guys you understood what is self join. So self join is not a separate like a separate type of join or the basic fundamental type of join. It's just a usage pattern, or we can say a terminology, where we join same table like twice, or like we can also join it multiple times as per our need. And then we have to use a standard join like left join, inner join as per our requirements. So we have seen the example with the help of inner join as well, also with the help of left join as well. So hope this video you finds helpful and you understood what is the self join. And if you do have any concept, or if you have any queries, so please do mention in the comment box, so I will try to answer those. And if you really learn something new today, and if you find this video helpful, so please do like and subscribe to my channel. So yeah, thank you for watching the video and happy learning.